Welcome to the Shearwalls online tutorial for the 10th version of the Canadian edition. In an earlier video, we talked about distributing forces to shear lines using a rigid diaphragm distribution and flexible diaphragm distribution. When we distribute forces based on rigid distribution, it is the shear wall stiffness or rigidity that determines how much force is distributed to each shear line and within each shear line to each shear wall. In this video, we will talk about two common methods of estimating the stiffness, capacity-based and deflection-based, and how each method affects the design. As you may know, capacity-based distribution is easier to calculate. This is where forces are distributed along a shear line based on the relative capacity of the segments. The capacity of the segments is then used to approximate the stiffness. In this example, the construction of the two wall segments are exactly the same, with symmetrical hold-downs on each segment end. This means that the 30 kN force is distributed to each segment in proportion to each segment length. This shear line has two shear resisting segments with a total length of 6 meters. The longer 4 meter segment on the left in this shear wall takes 2/3 of the 30 kN force, or 20 kN. The 2 meter segment takes the remaining 10 kN force. Please note that throughout this example, by looking at the legend, we will only talk about the shear line force. Intuitively, the two segments would deflect the same amount since the panels are all connected together with the same top plates. However, since the capacity distribution approach is an approximation, theoretically the deflections are not necessarily going to be equal. If we take a look at the deflection results, we can see that indeed the total deflection is not the same along the two wall segment. This is because the total deflection on each segment is calculated based on its respective shear force distributed to it. Using these deflection results from shear walls, the red lines in this figure represent the deflected shape of the shear line. Remember, in reality, we would expect a shear line to deflect as one unit, with each segment deflecting equally, but this doesn't always occur. Even though the deflected shape may not be 100% realistic, using capacity-based distribution is considered a valid distribution method in many codes and standards, including CSA 086. Now, let's take a look at the same shear line using the deflection-based distribution. For this method, we will expect the same deflection for each segment. To do that, the software iteratively distributes the factored shear line force to the segments until they deflect equally. This iterative process would be very time consuming to do using hand calculations or even a spreadsheet, but this software quickly completes the analysis. As you can see in this deflection table, using the deflection-based distribution, the total deflection for each segment is equal. The red lines in this figure represents the deflected shape of each segment. Because the deflection of the shear resisting segments are the same for deflection-based distribution, it is often considered the more accurate approach for distributing forces along a shear line. As the engineer, you sometimes need to use your judgment about the analysis. In this particular example, the applied 30 kN factor design force passes when capacity-based distribution is used. However, you may have noticed the elevation view on the previous slide for deflection-based distribution showed failed. In this example, the software determined that the first segment's design capacity was less than the calculated force by 3%. You would need to decide if the shear wall segment is sufficient. Now, let's demonstrate this example inside the software. Notice that this is the same structure used throughout the first part of this video. The link to download this file is available in the description below. Shearwalls distributes forces based on either the deflection-based distribution or the capacity-based distribution. You can select which one to use in the Settings Design tab. Selecting the deflection analysis opens the option to select the Use Shearwall Deflection to Calculate Rigidity feature, and in fact the software selects this option by default. Otherwise, this last feature will be grayed out and instead, Use Shearwall Capacity to Approximate Rigidity will be selected. Once we apply a point load of 30 kN on wall line B1, which has an opening of 2 meters with a 4 meter offset from the edge, we can run the design. By returning to the elevation view, we can see the influence of each type of distribution on the shear line, just like in the example showed in the beginning of this video. Again, this comparison demonstrates that in some cases, one type of distribution will generate a failure while the other will not. As the engineer, you will have to use your judgment to determine if it's necessary to modify the wall details based on the results, as mentioned earlier.